So am I live here? Perfect. So we'll kick this off here. So I'm going to be presenting on IBM FlashSystems. This is how we're going to take latency out of people's environments going forward. We are the fastest storage device on the market right now, and I'm going to kick it off with a little bit of a video to kind of set the tone of what I want to talk about. So if you want to.
Without a doubt, one of the most outrageous performance enterprises of the 1960s was the Turbonique Company of Orlando, Florida. Aimed at the drag racing market, their products consisted of three basic devices: AP superchargers, micro-turbo thrust engines, and rocket drag axles. All were designed for short use periods due to their use of a solid fuel known then as thermaline, its proper chemical name N-propyl nitrate. Their most outlandish device was the rocket drag axle, which connected mechanically to a car's differential and, when ignited, surpassed the engine's motive power and launched the vehicle forward at an astonishing rate of acceleration. Built by R.J. Reynolds' tobacco heir Zachary Reynolds, the Tobacco King 1964 Ford Galaxy was as wild an example of a rocket drag axle equipped car as one could ask for, and certainly reflected Reynolds' daredevil personality. Playboy, pilot, ham radio enthusiast, and all-around enfant terrible, Reynolds wanted a car that would terrorize everyone with its appearance alone, just before slamming their senses with a prodigious detonation of rocket axle power. The Tobacco King certainly fulfilled that mission. Reynolds replaced the Raven Black Galaxy's original engine with a Latham supercharged 427 fed by 4 Carter side draft carburetors, but that wasn't enough. Reynolds took the whole project the extra distance by installing an 850 horsepower rocket drag axle. The rest of the car had to be modified to handle the colossal acceleration of which it was then capable, and ground clearance increased to accommodate the huge turbine housing that shot its rocket exhaust out from underneath the rear bumper. The car's visual effect is simply stunning. From the front, it looks every bit the mid-60s AFX racer of the Thunderbolt variety, with drop suspension, dump tubes, and unpolished American torque thrust wheels. The picture is only completed by approaching the thing, if you dare, from behind, where the Black Simpson chute pack and twin large diameter tailpipes draw the eyes down to that alien-looking rocket exhaust pod. Inside, the Galaxy's stock instrument panel is augmented by a set of gauges to monitor engine RPM, supercharger boost, and the space-age bomb lurking out back. The ham radio installed beneath the dash speaks to Reynolds' passion as a ham operator. This was as crazy got in 1967, and is no less so for the years that have passed. Zachary Reynolds put a total of only 3,600 miles on the car before his untimely death in a 1979 plane crash in North Carolina, after which the car was placed in careful storage until recently. It is accompanied by early registrations, the original owner's manual made out to Zachary Taylor Reynolds, an original Turbonique product catalog with photos, the original Latham supercharger literature, and Zach's personal notebook. Unrestored and original, it is in superb condition inside and out, a delightfully shocking artifact that beckons to the daredevil in all of us.
All right, so you may have noticed that has nothing to do with IBM storage. So the one thing it's got in common is it's really, really fast. So if you're going to remember anything from this presentation, you're probably going to talk about the car, but at least it'll start the conversation again. So why IBM FlashSystems? Why now? So IBM has made a serious commitment towards flash within storage devices. So first of all, in 2012, we bought Texas Memory Systems, and that's where the heritage of this comes from. And then in 2013, they announced that they were going to invest an additional $1 billion in flash technologies to increase performance across their hardware lines. When they were looking at TMS, they could have bought anybody, so they were seriously looking at all the current flash vendors out there. TMS rose to the top. I mean, they have, I think we're in our 17th generation of the product. This is stuff that's been around for many, many years. This is stuff that is actually floating over heads and satellites in space. So we know that this is rugged, we know that it works, and we know that we don't have to dispatch somebody to go and replace bad parts up in space. I mean, that would be cost prohibitive. So we sort of run into a problem that we're trying to solve here. So Moore's law states that capacity and speed is going to double roughly every 18 months within a computer environment. So far, that's been fairly true. Processors, memory, hard drive capacity, but it hasn't necessarily been true for hard drive speed. So what we're talking about here is latency for storage products. And I'm going to tie this back into business value later here, but if you can follow with me, spinning disk typically has latency somewhere between 4 and 14 milliseconds, and that's if you're doing things really, really good. If we add solid state into those spinning disk arrays, we can typically get down to about a millisecond response time or so. And even if we're doing all solid state, we're still kind of getting down to that millisecond range. When we're talking about flash systems, we're talking about something that can do reads in 135 microseconds, writes in 90 microseconds. So orders of magnitude that are faster. When you start looking at CPU speeds, things get faster with every tick and tock of Intel CPUs or IBM power systems. 70 to 80% of all CPU cycles that your database servers or that your application servers spend are in a CPU wait state. They are simply waiting for data because of that fetch process from disk and returning back to the CPU, and then it has to do something with it. So what we're talking about speeding up our application environments within our data centers is cutting out that disk latency. What happens if we have removed 55 times the latency of what we were currently in our environment? Users and applications feel latency. They don't feel IOPS or transactions per second. So by impacting that latency in a meaningful manner, we are reasonably impacting our business applications. And that's true. We have customer references. We're seeing this all over. I have flash system installs in several locations in South Dakota for referenceable customers. I gave a presentation yesterday afternoon for a company in Fargo for a performance assessment that we did, and we are going to be able to reduce the latency by over 13 times within their environments. And that's real, meaningful results. What that means for them is that they're not going to have to hire the next 2 people as they scale up their business. And even a entry-level position in this area is probably worth $35,000 a year plus benefits, maybe $50,000 per employee. That's $100,000 that they're not going to have to spend, that they were able to invest in technology, and now they don't have to train new employees. They can work faster and do more work with their existing employees. So it's cost mitigation in some cases, and it allows you to scale your systems much, much higher. So what have we traditionally done to get where we're at and solve performance challenges? Well, adding memory, adding more CPUs, spending more on software licenses because we added more CPUs, adding more hard drives, scaling out performance across multiple hard drives within an enterprise storage array. Application dev work, we're redeveloping applications, we're tuning SQL, we're doing some of that kind of stuff. And what if we don't have to do that anymore? What if we don't have to invest thousands of hours in redeveloping applications? What if we don't have to pay more in software licensing just because we're trying to add more cores to solve this performance challenge? What if we can take out the latency from the environment, do more with less CPUs, save on CPU licensing charges for SQL or for Oracle or for DB2 or other database environments? We can do that now. All right. So some of the other stuff that we've seen is once we are able to justify this within an environment through a financial means, this is something that users want more of. I mean, this is, once you get used to going as fast as you possibly can, you want everything to go as fast as it possibly can. So it's very easy once we get this into an environment to start justifying more and more. And it's something that is very easy to get past executive management within a company. Investing in a company, it becomes very easy. So the IBM product is the Flash System 840. We have multiple solutions, multiple integration points, multiple ways of doing this that's very low disruption to users' environments. Everything comes out of the front or slides out of the back. It's all Hotswap, highly available. It has very, very few features for shared storage. It's really, really fast, not very smart. It's just really fast. So we can do capacity-based entry models. So obviously, we're not talking about something that we're giving away. This is what we would call fairly expensive stuff. But it can have meaningful business impacts to your applications. It's not for your entire data center. This is for targeted applications. This is for VDI environments. This is for terminal services and Citrix environments, database servers, or other high-touch user applications, whether it's ERP systems or other core systems within your environment. So we're targeting what we are looking at here just because this is cost sensitive. We want to make sure that we're tackling the right problem. 90 microseconds write, 135 microseconds read, and we scale up over 1 million IOPS on a box. So what that means is when you put it in, you're not going to run out of headroom. We don't have to add more spindles. Out of the box, it's basically a rock star. It's the rocket drag axle that you're attaching to your database server. So it's 2U, redundant power supplies, redundant memory modules. The other thing that we're doing that is completely unique, that is different than everybody else in the industry, is we are doing RAID across memory modules or memory chips within a module, and then we are doing RAID across memory modules itself. So we're doing two-dimensional RAID. The other thing that we do is variable stripe RAID. So if we have a block that goes offline, we can mark that offline, create a new parity bit, and not have to rebuild anything. So it allows us to just continue on at wire speed. The other thing is we're using eMLC in all of our flash system boxes now. Most, if not all of our competitors are doing MLC. So let me kind of level the playing field there. TLC, flash chips, are what we have in our cell phones. Consumer grade, they wear out over time, not a big deal. All flash wears out like the tires in your car. It can and will wear out over time, just depending on the kind of flash, depends on how many miles you get out of those tires. MLC is good for about 3,000 PE cycles, program erase cycles, before you have to mark a block offline because it is used up. eMLC is good for about 30,000 PE cycles before the tires on the car are used up and we need to mark that block offline. SLC, which would be the top grade, is good for about 90 to 100,000 PE cycles, write cycles, before it's used up. So we're using all eMLC in our flash system products. We do have some that use some SLC, but typically that's cost prohibitive for all but some very serious environments. The other common concern with flash is, since it wears out, am I going to lose data? So we over-provision our flash chips. So if our competitors use 100,000 blocks of flash to meet a capacity, we use 133,000. We have a 33% over-provisioning that we do to wear level across all of those blocks. So we're wearing out a larger tire, if you want to think of it, than our competitors. Together with our variable stripe RAID and not having to rebuild, and our two-dimensional RAID technologies, you could write 200 megasecond to this thing 24 hours a day, every single second of the day, and we will wear out in somewhere between 15 and 18 years. So this is something that's going to survive in your environment just fine. We have multiple integration options. So we sell the V840, which includes our enterprise virtualization nodes built into it. We also sell just the raw flash system, which can be attached over fiber channel, FCOE, InfiniBand if you're into that. We also can virtualize our stuff behind our Storwize products, so our V5000s, our V7000s, especially our V7000 Gen 2s, or our new SVC nodes. So our whole Storwize platform gives us those enterprise features that you probably come to expect in an enterprise storage solution. So I mentioned that flash system is really, really dumb. It's really, really fast. Literally all you can do is create users for administering it. You can do RAID group creation. You can Create your LUNs to provision storage to other hosts. You can do LUN masking to allow certain hosts to connect to it. That's it. We got 4 functions basically that we can do within FlashSystems besides observing performance. Typically in an environment we do replication, we do snapshots, we do volume copies, we do other things that matter for an enterprise environment. And how do we get those? Well, we use the external virtualization functions of the IBM StoreWise products. So we give it the ability to do snapshots. We give it the ability to do replication, copy volumes. We can integrate it as a tier within your existing storage environment. We have no problem with working with competitors' disk. We have no problem with making EMC, Hitachi, or any other storage vendor faster by using this as a tier within their environment. We can do that. We can virtualize external storage from other vendors. So we have multiple flash entry points within our environment. So we have the IBM FlashSystems, which is our raw flash environment. We also have flash drawers that go into our tier 1 components, whether it's our DS8 family. We also have eMLC SSDs in our StoreWise family. We can also uplift that to using an external flash system box for either easy tier, its own tier, or another instance within a StoreWise family using that external virtualization pieces. We also have, for our power customers, we have flash drawers, we have like extreme or PCIe flash cards that can go for persistent storage within our power boxes for AIX and Linux on power. We also have flash trays that can be attached to it as well. So it can grow within your environment regardless of what platform you're on. So we get down to this, and there's a number of things. People don't really buy this because it's cute. They buy it because it's really, really fast. You're not buying this because it's cost sensitive. You're buying this because it's really, really fast. This is solving business challenges in your environment. Obviously, you can improve workforce productivity. It's flash, no spinning disks, so we don't have to worry about power. We can save data center real estate because it's very, very dense. But typically, when we're doing this, it's for a pointed solution. So again, it's typically high user touch applications, whether that would be VDI, terminal services, Citrix, relational databases like SQL, Oracle, DB2, and then looking at specific core applications that are important to your company, whether it be an ERP package or for a hospital, an EMR system, something like that. So we're changing the way that you can do business. Analytics, we can make analytics go much, much faster. We just did a performance assessment for a company in Grand Forks where we are going to be able to turn an 8-hour analytics reporting load, where they're loading the ETL information, the bulk information into the reporting solution. It takes about 8 hours to do that. We're going to take that down under 20 minutes. The reporting workload in the morning is a 4-hour report generation process. It's going to happen in under 10 minutes. This is for a large company. This is going to meaningful impact their environment. They're running into window problems where they only have so long to generate the reports, and that data still means something. So this is going to give them value and be able to run a larger sample size across their data. We recently ran into a problem with a commodities trading business out of the cities, out of Twin Cities. They had an 18-hour process for sampling their data and running reports against it to be able to make commodities trading goals, information for supporting commodities trading. They were having problems because it was backing into their day. It was taking 18 hours, and so it was impacting their ability to do business the next day, along with financial impacts because they didn't have that report soon enough to make the trades during the correct time of the day. We were able to take an 18-hour process under 18 minutes. So we recently followed up with them. And they told us, well, it's running longer now. It's running an hour and 20 or an hour and a half. But we're doing 100% sampling across all the data. They were only doing a 20% sampling on their data when it was taking 18 hours. Now we're sampling 100% sampling across all the data in under an hour and a half or hour 20 minutes. So they're now making better choices with their money. So, like I said, this isn't meant to replace everything. This is meant to replace the very, very important and critical pieces within your infrastructure. This is meant for the high-touch, high-use circumstances. One more example that I have is we're working with a call center in South Dakota, and so they have metrics on everything. The time it takes for an employee to do this, or it takes an employee to do that. And we were able to run the ROI on there, and basically we allowed each call center representative to do roughly 30% more work during an 8-hour shift. So that has very tangible results where we don't have to increase employee count as we bring on additional business. They were able to scale up the business with their existing employees, save that retraining cost for new employees, that hire process. We were able to, as they bring on each new employee, let that carry them further and further without having to drastically increase headcount. So this is dramatic business changing stuff. So what I'm going to leave you with today is we do free performance assessments for our customers or our potential customers. What I mean by that is we can work with Network Center to get an example or a capture, whether it's Windows and perfmon data or SQL counters or Oracle AWR reports, things like that, and we can be able to represent exactly what kind of differences that you would be able to see within your environment. So we can give you a potential improvement, and we can also do trial systems through Network Center. So what I ask to you is if you have any critical applications, or if you have a slow application, I'm assuming that everybody probably has at least one problem child in their environment. Let us take a look at it. And if it would have meaningful business impact to make it 16, 20, 30, 50 times faster, let's look at it and let's run the metrics. And this is just a math problem. We're looking at the number of transactions per second and the amount of latency for each transaction. This is a fairly simple math problem. So let's solve the math problem. Let's observe what's going on, and let's give you some options for solving it. And we don't have to worry about investing in redeveloping code or redeveloping applications or anything like that. That's all the content I had, and out of all of the slides, I'm guessing that you'll probably remember the car the most. Any questions before I walk up the stage here? Perfect. Well, I'm around for the rest of the afternoon, and let you out a little early here, and I will be having beers in there later too, so feel free to ask questions. I'm happy to reference customers where I can name names. Other cases, I'm happy to reference the work that we did, but we've had a huge amount of success. So what I can leave you with is it's really, really easy to compete with our competitors when we're the best. I mean, we're over 5 times faster than our nearest competitors. So this is really neat to be able to solve problems and not really have to worry about competition. So it's kind of the state of everything. Perfect.
Hey, Kyle, one question.
Go for it.
If somebody wanted to have an evaluation done on a database or their system,
Yep.
what kind of time would that take for IBM to do that and get results back?
So AWR reports take a little bit longer. So if you have an Oracle environment, typically I like to say that it's a week turnaround time. Microsoft Windows environments, we can turn around the results in about 2 days. And if you are interested in doing such a thing, just engage with your Network Center rep or your contact at Network Center. They will bring me into this, and we'll get a document that describes how to collect the data. We'll go through and get that data, we'll work it, and then we'll do up a report so we can present to you and your executive or leadership team and put the choice back on you on whether you would like to pursue improving performance or not.
Is there any video of that car going?
I couldn't find any. And that makes me a little sad. So a rocket drag axle, 850 horse, bolted onto a 750 horse motor.
I want that.
That's acceleration. That's fast. Flash system's fast.
I'm sure it'd be fine in the winter in North Dakota too.
I'm sure. Yeah, let's just make the curve, right?
Yeah. I'd never do the Walmart parking lot.
Well, so if you have a rocket attached to the back, so I mean it's directly bolted to the differential, do you still have to worry about traction if you got that big old flame coming out of the back? I don't know that answer because it's going to spin the tires fast. Perfect. I'm going to take off the silly microphone and I'll be around here if you want to.
Thanks, Kyle.